All right, guys. In this class, we are going to look into another section of our functions, still on determining values of x, for which we are given conditions, all right? But this is to be done graphically. In our case, we are going to consider the product of two functions, whether it can be greater than 0, it can be greater than or equal to 0, it can be less than a 0, or it can be less than or equal to 0. Those are the two conditions. So if you check, we had a condition where the comparison is done compared to 0 before. This condition here, when we are comparing to 0. Comparing to 0, we are in the x-axis. We are saying whatever part that we are given is supposed to be compared to a condition that y is equal to 0. But this is a product of 2. So how can that happen to get a 0? It means one of these two must be equal to 0. But that's for an equation. When we say it is equal to 0, it is direct in the x-axis. But in our case, these values, they are greater than or they are less than 0. So meaning to say the comparison will be made from the two functions is going to be made according to the x-intercepts. If I am given two graphs, let's say I have got this quadratic function and also I have got a linear, all right, let's say something like this. What is important for the two functions, all right? Let's say these are the two graphs and this is our x-axis. What is important for you to note, which is your critical values, are the x-intercepts. The x-intercepts. Remember, we had a condition before where we are comparing f of x and hx, whatever that you're given. Maybe f of x is greater than hx, like this. When you're comparing both functions, you're comparing them. We said on that case, our critical values will be what? The points of intersection. The points of what? Of intersection. But when we are given this condition, guys, of a product of two, since we are to compare to say whether it is going to be positive or it is going to be a negative, we compare it along the x-axis, because along the x-axis, that is where we can see values above the x-axis being positive, below the x-axis being what? Being negative. So whatever that is going to be along the x-axis will be the what? The intercepts, which is the x-intercepts. So you target those ones as your critical values for this type of a question. Your major part or the critical values will be the what? The x-intercepts. Just like that. So knowing that your critical values are the x-intercepts, you can tell from there which part of the graph is positive. Anything that is above the x-axis is positive, anything below is negative. So this is the condition that you simply need. X-intercepts. You work from there. So now that you have got your critical values, you need to compare always. It's just like before I explained, guys, the issue of the critical values. You must have solutions from that. That is where you make a comparison from what you are given here. Is it that f of x is going to be positive or is it going to be negative? For you to get something that is greater than 0, which is to get a positive value. This can happen when a positive multiplies a positive. A negative to a negative. If you multiply this, you get a positive. If you multiply this, you get a positive. Remember, this is what? A multiplication. So in order for us to get something that is greater than or equal to 0 or greater than 0, it's either our f is supposed to be positive multiplied to g, which is also a positive, or our f is going to be a negative value multiplied to g, which is also a negative value. That is going to give us what? A positive. And in the case of getting a negative, it means we can have f of x being positive multiplied to gx being a negative. Positive times negative gives us a negative. Or it can be negative to a positive. That is going to give us also a negative. So you now make comparison from what we have, like in this region, we have got solutions, all right, in between these intercepts, the x-intercepts in between, we have got what? Solutions. After the x-intercept to the right side, there are also solutions. So it depends with how the graph is given. But that is the major case that you must expect whenever you are dealing with this type of equation. Critical values are the what? Are the x-intercepts. Then you make a comparison from there. So this is what I'm trying to say. Let us say we have got, right, I'm just going to put an example that we're going to use, just a sketch, all right? Let us just say we've got something like this. All right, I'm just going to put a sketch here. We have got a quadratic and also a linear, which is a straight line. So let's say we have got this is our f of x. All right, let's call it f. And there is a g, which is, right, an intercept here. All right, it is the same. Then it goes like that. Okay, so this is it. We have got something of this nature. Right, let me just have my f written this side so that it's not gonna be affected. All right, so like I said, we have got something like this. All right, and this is our g. Let's call it g. All right, a straight line. These two graphs that we are given, they do intersect. They do intersect at this point and also at that point, which is not important in our case, that intersection. What is important are the x-intercepts. So according to the two graphs, we can see that here it is the x-intercept for both, all right? It is for both, all right? Let's say this is -4, and here it is the x-intercept only for what? For the parabola, the quadratic function, all right? Let's say that is 1. So even if we knew the value here at the intersection, maybe it is a 2, it is a 3, whatever that you have there, it is not important. This at the intersection, it is not important. What is important in our case, the critical values are the what? The x-intercept, -4 and this +1. Whenever you are going to be given any question related to this part that we have on top. All right, so let's say this is our diagram, like we are given our f and our g. Then the question is to determine the values of x for which the product of these two, f of x and gx, is greater than 0. It can be greater than or equal to 0. It can be just greater than like that, which I said whenever it is greater than 0 like this, we must have positive output greater than 0. A positive what? A positive output here. That is what we're going to have. So to have a positive output, it is either both are positive or both are what? Negative. So this is what we are going to consider. All right, so it is for us to have a positive here. So this can be positive, positive, negative, negative. From where the critical values, your x-intercepts. So at the x-intercepts, draw your vertical line so that you can properly see the regions that are separated. So this is it, our x-intercept at what? At -4, and x-intercept here at 1. That is what is important, your critical values, all right? The rest ignore. The point of intersection is not important. Here it's a coincidence that the x-intercept is also a point of intersection. All right. Anyways, that cannot stop us to answer our question. So as we can see, we have got three regions where our solution can be found. There is this, the -4 going to the left. There are solutions in between -4 and 1. There are solutions from 1 going up, 1, 2, 3, and so on and so on. Three regions that we have. All right, so this is 1, 2, and 3. So let's check. In the first region, does this satisfy our condition that both are positive or both are negative? All right, let's check our F. Remember, being positive, you compare with the x-axis, above the x-axis. Anything that is found above the x-axis is positive, like I explained here. Anything below will be negative, all right? So let's take at the point of, at the x-intercept here, our F is above the x-axis. It is found on top, whereas our G is below the x-axis. So remember, above, positive, above the x-axis. Below the x-axis, that's a negative. So if I am going to multiply these two, positive and a negative, it is not applying because we must have positive, positive, negative, negative. So this is not satisfying what we need according to the question being asked. So it means this first region, these values -4, -5, minus going to the left, they do not satisfy our solution. So this is wrong. So it follows that we are going to have another one that we check. So it means also we have to check another region from -4 to 1. All right, let's check that part -4 up to 1. From -4 up to 1, remember the point of intersection. I mean, the x-intercept. Sorry for that, guys. I'm now confusing you. The x-intercept is 1. Here it is what? -4. So in between, let's check what is happening. F is below the x-axis. Remember, this is your x-axis, and our F is below. In this region, from -4 up to 1, it is found below. Here, look at it. It is below the x-axis. It is in the negative region, below the x-axis. Whereas our G in that interval here from -4 up to 1, as you can see, it is above, on top of the x-axis. It is above. That's being what? A positive. So we still have the same condition. One is positive, another one is negative. So this does not satisfy our condition because both must be positive or both must be negative. If you multiply this, you're not going to get a positive. So that means that region also is what is wrong. So this is wrong. Moving on from 1, which is our x-intercept, going to the right side. All right, let's check what is happening. F is now above the x-axis, on top of the x-axis. That is being what? That is being positive on top. So our F is positive. And as you can see, our G is already on top. It is still on top like that. It is a positive as well. Our G is positive. So this is exactly what we want. A positive multiplied to a positive will give us a positive. So this region satisfies our solution, which is the final region from this critical value where x is equal to 1. From there, going to the right side, these are the solutions from this one, going to the what? To the right side. So meaning to say x will be greater than, x is going to be greater than 1. X is bigger than 1. For those values that are greater than 1, we are going to see that the product of the two functions will be greater than 0. So if there was an equal to here, you're going to also put an equal to there. That is what it means, right? But in our case, it's just greater than. So what does it mean about these two regions, which we say they do not satisfy this condition? It means that is the one that will satisfy the other part when it is less than. Let's say the question was f of x by what? By gx is less than 0. So it can be less than or equal to, it can be less than 0. Where the product of these two is supposed to give us what? A negative value. That is where those two conditions that failed here will satisfy this one. Because one has to be positive, another one a negative, to get a negative. And this is exactly what happened in the first region, this one, for values that are less than -4 to the left. F is positive where G is negative. So it means this time it satisfies for this inequality that was going to be part of our solution. X is less than -4 to the left side of what? Of -4. So X is less than -4. If there was an equal to, you also put an equal to there, but it's not there. But we saw that there's another part also satisfying this condition in between -4 and -1. The one that failed before. This is positive, this is negative. So it's another solution that we're going to take again to say x is going to be greater than -4, but the same x is less than 1. In between, always in between, x will be in between what? The two numbers, all right? Your boundaries. So this was going to be our solution. What failed for the other given question satisfies another one. So when you are making revision, revise both because you do not know exam which one are they going to ask. So when you're answering question, do not just focus on the question that you're given. Also ask yourself to say, what if the question was going to be asked like this? How am I going to answer this question? All right. But in this case, this is it, guys. Just make sure you do revise as many questions as you can. So we saw that what measures when we are given this are the x-intercepts. All right. The x-intercepts for the given what? For the given graphs. And it is important that when you are dealing with a hyperbola, you work with the asymptotes will be your critical values. You must also put that the asymptotes whenever there is a what? There is a hyperbola. But for any normal graph that you can be having, x-intercepts, all right? A hyperbola, remember, it is also, it has its own properties of the asymptote. So whenever you deal with a hyperbola, you must consider the part of the critical values. You must also consider what? The asymptotes. All right. So we are going to look into that one if we have got questions later on. All right. But for now, let us consider this a typical exam question. They gave us a diagram. It was September 2018, Free State Province on question number 4. So I'm not going to go through the question, this and that. I'm just going to focus on our question, which is answering questions of this nature. For which values on question 4.6? For which value, all right, it was supposed to be value or values, all right, of x is hx by what? Gx less than 0. So we had two given graphs, all right, the graph of h, all right, which is the graph of h was our parabola, the quadratic function, this one, all right. So they gave us this as our graph of h. This is the graph of h. And we were also given g, which is the graph of g, this one, which is a straight line, a linear function like this. All right, that was the condition of our question. So they're asking this part to say, where do we have the product hx by what? By gx less than what? Less than 0. Remember I said whenever we've got something like this, the critical values is what is important. Our critical values are the what? Are the x-intercepts. So in our case, they gave us, you were going to calculate these according to the function that you're given. So I'm just going to give you these values. At p, the x value was -2. All right. And here at R, the X value was a +10. It was a +10. All right. Do not worry about this one at the intersection at E. As we can see there at E, we have got what? We have got the value of X there being what? Being 6, which is the value of X corresponding to E. It is not important because of what? The critical values, x-intercepts. So at the x-intercepts, draw vertical lines, all right? These are the x-intercepts, all right? -2 at P. I'm just going to have a vertical line there so that I can make a comparison, all right? Passing at P, all right? Then the other part is at R there, at R, all right? Just going to have a vertical line passing through R there. Those are the critical values, -2 and 10. We must have these values on our answer, one of these or both, depending with the solution. So the question here is that, where do we have the product of the two less than 0? So it's either to get a negative, it's positive to a negative or negative to what? To a positive. So let's check. From -2, there's a region here on the left side of -2. What is happening? We can see that our H is in the negative region below the x-axis. Remember, our comparison, guys, is always to the what? To the x-axis. It is below the x-axis. That's a negative. Even our G, it is below the x-axis. That's a negative. Both are negative, so you cannot get a negative. So this region fails. We move on to the second part, the second region, in between what? -2 and 10. Between these two, we can see that from -2, our H is above the x-axis. From -2 up to 10, it is above the x-axis. That's being what? That's being a positive. And our G is also above. Look at G. It's above the x-axis. Also a positive. So this is exactly what we want. All right. Sorry, guys. Sorry, guys. Positive, positive. No, we do not want. We need positive, negative, negative, positive. So this one also fails. The region in between -2 and 10, it also fails. So we move on to the last one. Values that are greater than 10 on the right side. This side going like this. So you can see that this side, our H, as we can see from this point arrow there going down, it is what? Negative. It is below the x-axis. That's a negative. Whereas our G is a positive because G is continuous. Guys, G is continuously going like that. It is going up, is still in the positive region. Wherever we're going to have it to be in the positive. From 10 going this side. H is negative, but our G is positive. This is exactly what we need. The product of these two will give us what? A negative. So we need values from 10 going up. 10, 11, 12, 13 for the x values. Remember, we're solving for x. So therefore, x is greater than what? Is greater than 10. If there was an equal to, you're going also to put that equal to, but we do not have that. So this was going to be your solution. But remember what I said, guys. It's only that here we are answering a specific question. But what I said is that whatever that fails here, the one that we said it is failing, it satisfies another condition. What is it? The region that failed here satisfies another condition where the product of these two, hx by gx, let's say the question was greater than, instead here they say it is greater than 0, where we are going to get what? Positive values. It means these regions that we say they do not satisfy before, they are going to satisfy for this one. Which region are we talking about? These values less than -2, where both are negative, because it's either both are negative or both are what? Positive. So it is happening for values that are less than what? -2, or in between -2 and 10. We saw that one is positive here, the other one is also positive. It is above the x-axis, so that one, both are positive. So x can be greater than -2, our x-intercept, but less than what? Less than 10, our x-intercept again. So that is how you're going to answer if it was like this. But in our question, we are answering this, guys. According to here, we are answering this part. This is our solution for values that are less than 0. So that is how you play around with these questions. Just revise as many questions as you can. Where you do not understand, let us use the community section. Send your questions on the community section. Join membership for more, so that you do not miss anything that we are going to have from Maths Zone African Motives. Till we meet again.